We are making short videos of each of the main players for the Micro820 controller platform. This one is going to be for the 820. We have CCW open. I'm going to new, and we'll just call this a Micro820. Create. Let's pick our controller. And of course, you know I like the QBB, the straight on DC version. Now notice that where the 810, you could have as early as version 1, and as late as 7. With this one, you have a whole different range, starting with 6, 7, 8, 9, 10, and 11, and then now 12. And there's our 820. Right away you notice that there's a little more to an 820 than an 810. Probably the most noticeable, just at the image, are these two plug-in module spots here. And you see as I click on these down below here, I can actually select it here or here, but I can go to plug-in modules, right click on empty, and I can pick different types of modules. Now I'm going to, just for grins, I'm going to pick an IF2, then I'll go to this one and pick an OF2. So now I have 2 analog inputs and 2 analog outputs. Now notice that there are no expansion modules for this. If you're using an 820, you have 2 plug-in modules that you can expand with, and that is it. If you want to set up the RS-232 or the serial port, you select serial port, and here you can pick the driver and the baud rate and the parity. Ethernet, this is where you would set the Ethernet address and the subnet mask. Looking at your embedded I/O, again, you can set up filters. The default is 8 milliseconds. And you have 16 and 32 to pick from in groups of 2. You have 12 inputs. Remember, this is an LC20. And then you have gain and offset for input 0. These are your analog inputs. And this is for the embedded I/O, not the plug-in modules. If we go down and pick the input, analog input module, pick configuration, and now it's a 2-channel input. So we can set it up for current or voltage, and we can have a filter, and we can enable or disable that channel. We can do the same for both, and they don't both have to be current and both voltage. You can have one of each. Then if we go to the OF2, specifically configuration, you see the same type of setup. So this is an LC20, and the LC20 has much more power than the LC10. Now I'm going to delete these modules because we're not going to be using them. But we didn't have to do analog modules. We could have used analog, communication, digital, and specialty, high-speed counter, and trim pots. The big advantage that the LC20 has is that it has Ethernet IP. And I didn't remark for the 810, but the 810 has no path for upward migration, whereas the 820, you can change the controller. So once you've created your program, you could, if you decide you want to use a different controller, you can go in and actually change the controller. So you can pick from LC20, 30, 50, and 70s. You can't do this with the 810. There's no upward path from the 810. You can't change the processor. You have to do a lot of copy, paste to get things from the L10 project into the 820 or vice versa. Maybe an easier way to look at each of these processors is to actually look at the documentation from, and you see the Micro820 right in front of you, and this is the exact model that I use for development and that I recommend as the most bang for the buck. Primarily because it has Ethernet. The 830 does not have Ethernet, and the 810 does not have Ethernet. This has 2 plug-in slots and no expansion capability. We'll go down to the specifications, and by the way, as long as we're passing by this remote, this is a nice little unit. Coolest thing about it is that it has a USB port on the front under that rubber connector plug. And you can see the quality of the resolution on the screen. It's a nice little display. If you have a small machine, this is a good solution. Looking down at the specifications, the QBB, the one in the middle right here, notice that it has 12 DC or AC inputs, but it's not 115 volts. It's 24 volts DC, 24 volts AC. You see, the only one that has 120 volt AC inputs is the AWB, the bottom one of the two. Now, I avoid any finger contact with 120 volts, anything over 24 volts DC, when I buy units to use for training. Notice that they all have 4 analog inputs, but these are not separate inputs. These inputs are shared with the digital inputs. So in other words, 4 of the digital inputs can be used for digital or analog. There's only 1 analog output for any of these Micro820s. 2 of these have relay output. And the advantage of relay outputs is current capacity, and that you might be able to switch different voltages if the commons are separated. Again, I use the QBB, which is a straight up DC, 12 DC in, 7 DC out plus 1 analog. And then you see the list here of plug-in modules, I/O expansion, like here's a nice one right here, IQ4 OB4. That's 4 in and 4 out. What I wanted to show you here was this is the units with the W in the part number. If you compare the QBB down here with the AWB, WBR up here, the input looks identical. In other words, you have 2 groups. Input 0, 1, 2, and 3 have a common, and then inputs 4, 5, 6, 7, 8, 9, 10, and 11 have another common. Then in the outputs, this is the relay output. Notice that you have output 0 has a common. Output 0 right here, pin 7, that has it's a common. 1 has a common. 2 and 3 have their own common, and then 4, 5, and 6 have their own common, which means you technically could have 3 different voltage levels being switched. Whereas with the QBB down here, it's just straight up DC. But you still have groups. So here's output, digital output 0, 1, 2, 3. So you have 4 outputs here that are on one common, and then you have another 4, 5, 6 right here, 7. So you have 2 groups. So you could do 2 different DC voltages, or you could do 24 volts DC on one, 24 volts AC on the other. So those are the 820s. This is my LC20 development station. Remote LCD has 5 connections on the bottom. There's 2 down here for power, and then 3 for communications. So I have 24 volts DC. Looking at the back side of this little HMI, you see that you have 5 connections down here. Actually, you have 6 if you want to count ground. You can't see this on my unit because it's on the edge. And on the bottom of it, it identifies what these terminals are. The ones of interest are common or ground. So these 2 are hooked together right here, ground and minus. This goes to 24 volts DC of your system. And then this is receive and transmit for RS-232. DC connected to these 2 terminals. You can't see them, they're down below here. Then there's 3 connections over here, and you see all the conductors moving along here. 2 of real interest to us. You've got 24 volts DC, you got 0 volts, which is the black common, but it's the yellow and purple that come over to this toggle switch. Also to this toggle switch, we have connections coming from this DIN rail mount 9-pin sub D shell to terminal block adapter, and you see the yellow and the purple wires. So the yellow and the purple wires come from this RS-232 9-pin sub D shell adapter, and it comes from the 3 terminals down here. They go to a double pole, double throw toggle switch. So the switch can pick between these yellow and purple wires coming from the remote LCD and these yellow and purple coming from the adapter. That way I can use the USB connector, or I can use the RS-232. This particular design uses a power adapter that plugs in right here. You see there's another connector right next to it. Those are connected in parallel. So you can use a jumper cable from here to an analog field device simulator or anything else that you want. I also connect them up externally with the fuse, so if I want to power something external like a sensor, I can do that. And that's all of these terminal blocks right here are all connected up over here to inputs and outputs to afford me direct analog input to the 4 inputs that share both digital and analog, and to the 1 analog output right here, the yellow block. These are just in case terminals. You don't need these, but they're so cheap to do, it's not a bad idea. I like to consider all possibilities for the future. Now this is an analog input module here that I use for a specific demonstration and video that I recorded. It has a better resolution than the 4 analog inputs that we have wired up here.